Welcome everyone, welcome, 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 and thank you for attending the first part of our 6-part series on YSI sensors. We're launching this series today with a very popular topic, how anti-fouling works. And we are extremely fortunate to have with us 2 guest speakers from YSI who have woken up very early to join us on what is currently their Tuesday morning in the United States. Our first guest speaker today is Curtis Butler. Curtis worked in repair and technical support before becoming an application specialist and has been with YSI for 14 years. Curtis is responsible for supporting the sales team, key customers, and managing our test sites in Florida, where we challenge our equipment with some of the harshest biofouling environments in the region. Our second guest speaker is Carrie Hubbard. Carrie has now been with YSI for 2 years as a product specialist for outdoor water quality and has over 10 years of field experience with water quality monitoring and flow monitoring. Carrie maintains a site in freshwater urban environment. Now, before we begin, I'd quickly like to draw your attention to your GoToWebinar screen. You probably noticed that you have been muted. All attendees are muted to eliminate any static or background noises and generally improve the overall webinar quality for everyone. We will be holding a Q&A session at the end of the webinar. And of course you are encouraged to join that session simply by typing in your questions in the question box on your screen. Feel free to type a question at any time during the session and your questions will remain in queue. And if we don't have time to address your question in this webinar, one of our staff will of course respond to you offline throughout the week. Finally, a follow-up email will be sent at the end of the webinar to everyone who registered. The email will include a link to the recording of this webinar, in addition to a certificate that can be downloaded. So please keep an eye out for that email in your email box. Our webinar today will cover freshwater fouling, marine fouling, evolution and principles of anti-fouling technology, and finally recommended cleaning procedures. All right. Let's begin the webinar with a very quick poll to understand our audience a little better. The first poll question is, which environment do you work in? So we're going to launch a poll on your screen and we encourage you to answer. So which environment do you work in? Please select one of the below: coastal, freshwater, or both. We'll just give you a few seconds there. Which environment do you work in? Terrific, we're getting a great response from these questions. And Carrie, I'd like to invite you in now. And what do you think of the responses by our audience?
I think those are great responses, and I appreciate everyone's feedback, and we'll definitely cover the freshwater and the coastal environments pretty well. So I hope that you all are able to learn something from us today. So thank you, Michael.
Thank you, Carrie.
So again, thank you, Michael, for the introductions and the whole team for getting this webinar set up. So Kurt and I are very excited to speak with you all today, and we'll get started with a discussion on freshwater fouling. So freshwater fouling types change depending on the site. So for example, is the site downstream of many agriculture fields? Is there a lot of residential or industrial construction with limited sediment control? Is the stream in an urban area that has highly variable discharges during storm flow? Or maybe the site's a highly productive ecological environment with many animals in the area. So we'll take a look at each of these for a moment. The first type of fouling that we will look at is soil or sediment. There are different types, including sands, silts, and clays. These sediment types tend to change as flows change as well. So the heavier sediment particles will be carried to the site during higher flows, and they'll deposit on the sonde as flows decrease. The smaller particles, like sand, tend to remain suspended in the channel during base flow conditions and can shift whether there are storms or not. Some types of sediment also have metals that can cause the appearance of staining, but these stains can be removed, and we'll talk about that in a bit. So the central wiper is going to be an important tool for ensuring the removal of sediment from the sensor faces. Leaves and other natural debris can enter the sonde guard, which will cause spikes in the data, especially in your optical sensors like in the turbidity record seen here. If the sonde guard is actually full of debris, all of your sensors can be affected. Leaves and debris tend to be more of a fouling source during season changes and during large storm events that bring those larger objects into the water body. Adding mesh around a sonde guard can help prevent leaves from entering the guard and affecting these readings. You wouldn't think that animals would be a source of fouling, but honestly, they're frequent causes of fouling. Many smaller animals, such as this little crawfish, like to climb into the sonde guard and like to hang out in those sonde deployment tubes themselves as a source of food and shelter. From personal experience, I can say that I've had a 4-foot long snake wrapped around and inside my sonde guard, which was an unexpected surprise. Animals like beavers drag debris into bodies of water, and this debris can cause the sonde to become fouled. Adding guards around the deployment tube and sonde guards may help alleviate some of the effects of animals on the sondes and the data. So the top panel here shows the chlorophyll A readings from one of our 6 series sondes, which had a mechanical wiper on the sensor. The yellow dots are chlorophyll A extractions of samples collected at that same site. On the bottom is a competing high accuracy chlorophyll sensor that is still sold on the market today. So this sensor has been pegged, meaning that the sensor thinks there's an amount of chlorophyll that is maxing the sensor range out. That's because light is not penetrating the biofilm that's on the sensor's base. There's a growth of algae on it. So all that signal from the biofilm is directly reaching the photodetector. So copper can help in these algae-laden bodies of water because copper is toxic to most organisms. In this example here, we have a copper sonde guard that was used in the deployment. As you can see in the picture, this was a high fouling environment, but the sonde guard doesn't have hardly any growth on it. So the last type of fouling that I will talk about in freshwater systems is what I call urban scum. So you can think of urban scum as anything that comes out of a sewer or things like garbage that have been improperly disposed of. These things like toilet paper or cigarettes or films caused by grease can cause varying effects such as spikes or slow drifts in sonde data. And again, that central wiper will be key in keeping the sensor faces clean of this fouling. So, all right, now I'll turn the show over to Kurt for a bit for a discussion on marine fouling.
Thanks so much for that segment, Carrie. I'd just like to take a moment to echo Carrie's sentiments and tell you how happy I am to be with you today. There are many types of marine biofouling. Depending on your site, you're likely to run into any or all of these types. You may come up against barnacles, bryozoans, animals, and sea plants, just to name a few. The picture shows a couple of my test sondes that have been in the active biofouling environment of the Gulf of Mexico. This was after 5 weeks in situ, and although I protected the sonde's bodies, you will notice that I took no additional precautions on the top side of the sonde. This area can be very time consuming during cleanup, and we will discuss some ideas near the end of my presentation that can help us save some time in this part of the cleanup. It can be a little alarming to think that in as little as 1 minute, the biofouling has already conditioning your equipment to set the stage for further growth. In as little as 1 minute to an hour, microorganisms are conditioning the surface areas of your equipment. This conditioning layer is the foundation for biofilms that can start forming in an hour to a day. This biofilm in turn lays the foundation for colonization growth that can occur from 24 hours to a week, which finally leads its way to the hard barnacle type growth. Any or all of these stages of biofouling can negatively affect the quality of your data if we do not employ countermeasures to fight against them. If it were not for the EXO central wiper and the copper accessories employed on this sonde, this bryozoan would surely have impacted the data on this deployment. The central wiper, along with copper tape and anti-fouling sensor guard, we're able to keep the sensor faces clean and collecting high quality data throughout the entire deployment. You may find that all types of little sea creatures like fish, crabs, and snails may find the safety of your sensor guard to their liking. If these little guys are present when the sonde takes a sample, you could have interference with your data. You may find that you need to cover the sensor guard with copper mesh to help deter them. The reason I like this type of flexible copper mesh is that it can be formed to fit snugly around your sensor guard. And if you're using a PVC pipe for deployment, it will scrape off very little anti-fouling paint from the inside of your tube when pulling your sonde in and out throughout the year. These are pre-deployment images of EXO-2 sondes at 2 diverse sites. The left image is of a buoy system deployed in the high fouling application in the North Sea. The right image was taken at our highly productive YSI R&D sites in the Gulf of Mexico. Now we see post-deployment images of the same 2 EXO sondes taken during the recovery of the instruments. Notice the variety of fouling displayed, ranging from hard growth build up inside the sensor guard on the right. The left photo is a good indicator of what a deployed monitoring system can look like in highly productive environments. What's most important to see here, however, is not the accumulation of fouling on the sonde itself, but rather how the sensors and data are affected. These photos demonstrate the power of the EXO central wiper in maintaining the most critical aspect of an EXO-2, the sensor head where the measurements are taking place. Now I will turn that thing back over to Carrie for some information on the evolution and principles of anti-fouling technology.
So thank you, Kurt, for that informative discussion about marine fouling. So there are certainly differences between freshwater and marine deployments, but there are also similarities in how these can be taken care of. In the next couple of sections, we'll talk about some anti-fouling technology over the years, and then we'll talk about how to properly clean and set up your equipment for a lengthy deployment. But before we get into that, let's get some more audience participation here with another poll question. So Michael, if you please. So this question, we'd like to know, how are you guys using your sonde or other monitoring equipment? Are you doing spot sampling, unattended logging? Are you telemetering your data from a data logger, or maybe you're not monitoring yet? All right, that's some interesting looking data. Looks like we got a little bit of everything. All right, so we'll hop back into the presentation here and we'll talk about a little bit of this technology. So the earliest multi-parameter sondes were pretty basic, kind of like this slide. So not much going on as far as anti-fouling because only one sensor had a wiper on it, and that's the turbidity sensor. So these sondes required pretty frequent servicing for cleaning of the sensors. So these concerns were acknowledged during the development of the next series of multi-parameter instruments, which you all may know as the 6 series. In this series, we incorporated a wiper on each optical sensor to try and extend those deployment times. During the life of the 6 series sondes, we also began to incorporate the use of copper. So copper has actually been used on the bottom of ship hulls for many years to prevent the accumulation of barnacles. So the barnacles accumulating on the bottom of ships can actually make the ships so heavy that they sink when an additional load is added. So taking a hint from the shipping industry, if it works for them, it ought to work for us. And it sure does. So the most recent equipment that we have developed is the EXO-Series of multi-parameter sonde. The EXO uses a powerful central wiper to wipe all of the sensors that are housed on the sonde. What's nice about the EXO is that all of the sensors have been specifically designed to be wiped. First, they are all on the same plane, which is how one brush can be used instead of multiple. Next, we've developed a wiped conductance sensor with a U-shaped channel that allows the brush to wipe the electrodes completely. Finally, we've also developed unguarded pH, ORP, and ISE sensors. So the normal guarded sensors have a little ring around the outside of the bulb that's for the protection of the bulb. The unguarded sensors have this ring removed so that the wiper brush can adequately wipe the bulbs or electrodes of these sensors. Also, we incorporated the use of copper again in the form of copper tape and copper sensor guards, but we also developed heat shrink sonde and sensor sleeves to help keep debris off of your instrumentation. So this is our central wiper. It's a standalone sensor that can be calibrated just like the other sensors, but its calibration is solely to make sure that it parks in its little parking garage. I would recommend that you log the wiper position over time because it's going to tell you if your wiper is parking incorrectly, which could be a result of debris blocking the brush or general wear of the sensor over time. So you can kind of see a graph of that right here in this image. So the wiper brush itself is a replaceable item, and as the bristles fray, we suggest that you do replace them for the best protection from fouling. Fray can be caused by general wear and tear, sediment being trapped inside the bristles, or biological growth. Whenever you clean the sonde, make sure that you clean the bristles of the brush as well. So in this series of images here, we see the progression of a wiper brush over time. It starts out new with all of the bristles together and then wears a little bit, showing some fray. By the time that we have this amount of splay in the bristles here with this third wiper brush image, we really need to replace that brush. Some groups also choose to monitor the water indirectly as opposed to deploying the sonde in a tube directly in the water. In the image on the right here, we have a Pisces unit that pumps water from beneath it into one of these yellow boxes. Inside the yellow box is a flow cell chamber that's attached to the sonde. Fresh water is pumped in and old water is pumped out during every sampling cycle. A similar operation is taking place in this image at the bottom of the slide here, but instead of using a flow cell, water is just purged out and then fresh water is pumped into a tub for fresh readings. So using these types of deployments help keep some types of fouling, like leaves, from becoming a problem because a strainer is typically deployed on the end of the tubing used to pull water in, and that keeps much of the debris out. A couple of other types of equipment that people have been trying out in the field as of late are the ultraviolet light and the air pump. Ultraviolet light has been shown to slow or stop microbial growth. An air pump could be used to blast a jet of air on the faces of your sensors to blow off any sorts of sediment contamination. Some groups have been connecting air pumps to their data loggers and powering them on before their readings are to take place so that the sensors are as clean as possible for that reading. So there's a variety of air pumps and UV lights on the market, and these pictured here are examples only, and I have personally not tested either of them. So if you guys are using any types of equipment like this that you would recommend, please feel free to share that information with us. And for the last part of my section, I really want to highlight the importance of telemetry as a piece of the anti-fouling puzzle. So connecting your site to a web-based data hosting platform can allow you to easily visualize your network of sites and data. In this first image here, you can see how quickly that an issue with the pollution source could be spotted, fouling could be identified, or potential algae blooms could be monitored. So graphically viewed data is a tremendous help when it comes to spotting trends and issues in data. Having the ability to view this data from your computer at Starbucks, your office, or your couch at home can help you really determine if a visit to your site really needs to take place. So also, real-time data telemetry sounds like a complicated thing to set up, but realistically, with a few simple clicks, you can be logging your data and seeing it live. Then you can see your site displayed on the map like we have shown here in the next couple of pictures. So maybe you have a site near the coast like ours at the YSI ISS office in Massachusetts, or maybe you're monitoring on a canal like another team does in Florida. So by geotagging your stations, you can take a peek at some data simply by clicking on the name, or you can also identify where alarms have been triggered. None in these locations right now. So this program is called Hydrosphere, and Hydrosphere can also be your behind the scenes friend and can alert you if something goes amiss without you having to continually look at the data. I won't get too into details here since we recently presented another webinar about telemetry, but just know that with our tool, you can get alerts if anything you don't want to have happen at your site starts to happen. And on the next slide, I'll show you an example of an alarm. So in this picture here, you can see that something caused my turbidity to rise on the night of April 14th. When I actually visited the site on April 16th, I found a bunch of leaves trapped in the sensor guard and removed them, which led to the drop here. What is nice though is that I was actually alerted to the fouling by an alarm that I had set, so I knew that something was going to be affecting my sonde even before I logged into Hydrosphere. In this instance, I set an alarm to trigger if my turbidity value most recently reported is greater than 30% higher than the average of the last 96 samples. So 96 samples in my case is 24 hours of samples. So in essence, I'm looking at answering the question, is my current sample much higher than the average in the last day? However, we all know that storm events are really going to skyrocket those turbidity values higher than what is found at base flow. So I also added a second condition that says that the water level must be less than 1.95 feet. So base flow at my site is around 1.85 to 1.9 feet. So this threshold allows for me to account for some possible inputs into the stream from spills or releases as a trigger for my alarm, but does not allow the alarm to trigger based on rain events. So, all right, Kurt, it's going to be your turn again. So I think you got one more poll, and then Kurt's going to take it over to explain some of our recommended cleaning procedures. So, Michael, if you don't mind with the next poll question, please.
So in this poll, we're asking, what is your typical deployment length before servicing your sonde? 1 week, 2 to 3 weeks, 4 to 5 weeks, 6+ weeks? Give that a few minutes. So typically, and that's pretty much been my experience also with the dominance being in the 4 to 5 week period. I appreciate you taking the time for that poll, and thanks for the help with that, Michael. I want to encourage you also to send your questions in using your control panel. I don't know if it's nerves or what, but we appear to be flying through this presentation, so we're going to have plenty of time at the end to answer questions and probably have you back at your dinner tables a little sooner than you may have expected. Thanks so much for the interesting feedback on that poll, and I'd like to share the 3 major reasons that I pay so much attention to anti-fouling technologies at our test sites in Florida. Obviously, we all want to make sure that we collect the highest quality data possible, regardless of the length of our deployment time. This is the most important point when applying anti-fouling accessories. We have to keep the fouling at bay in order that our sensors can collect the data that has not been interfered with. The second reason is that the longer that we can leave equipment in the field without going out to do routine maintenance and calibration, and the lower the overall cost of ownership of our equipment is. This savings in time and money can be spent on more important scientific endeavors. Lastly, the reason that I spend so much time trying to come up with ways to beat the fouling is that I hate to clean sondes. The less time I have to spend cleaning my sondes between deployments, the better. Now let's spend a little bit of time talking about, excuse me, how to take care of cleaning off all the biofouling that will likely build up on the sonde during deployments. Whether you're doing your cleaning in the field or in the lab, there are important items that you should always have on hand to help you with the cleaning process. Lint-free cloths. It's very important that if you're using paper towels to clean your equipment, particularly the final wipe down, that they must be lint-free cloths. The use of regular paper towels can actually leave behind paper particles that can fluoresce and could potentially impact optical readings for sensors like turbidity, FDOM, total algae, and the new rhodamine during calibration. Any of those sensors that are looking for feedback on items that fluoresce. So that's why we want to make sure that we don't leave any paper particles on the equipment before calibration. You will want to have on hand a variety of cleaning solutions like Simple Green, white vinegar, and scrubbing bubbles, bathroom cleaner. Having a wide range of brushes with different bristles can also be very helpful. From a small brush like a toothbrush to help get into tight spots, to his toilet brush, which happens to be the perfect size for cleaning the inside of your sensor guard. I like using a small, soft brass bristle brush for cleaning around the sensor retaining nuts. This works great for dislodging hard fouling that likes to get into the little holes on the retaining nuts. Cotton swabs and sponges are very helpful also. Just remember to thoroughly rinse away any particles that might contaminate your calibration standards. It's always a good idea to have a variety of different blades and scrapers available to aid in the cleaning process. You will all come up with your own favorite items over time, and each one has individual characteristics that help clean in all the little hard to reach areas. One of my go-to tools is the putty knife. It is terrific for scraping hard barnacle growth off the sonde body, and particularly the upper section of the sonde where the sonde bail, battery cover, cable, and auxiliary connectors are located. If you remember back to that first slide that I showed you that had all of that horrific barnacle growth up on the top side of the sonde, that area is very time consuming when it comes to cleaning between deployments. If the hard fouling is too difficult to remove, remember, you can do an overnight soaking in white vinegar or a short soaking in 1 molar HCl solution, no longer than 15 to 20 minutes in the HCl solution. This is one of the reasons that I prefer to use the white vinegar over HCl. If you walk away and forget, get busy doing something else, and leave your sonde soaking in vinegar, it's not going to damage the sonde and sensors. Start by rinsing the sonde with fresh water or a mild dishwashing soap solution, moving on to stronger cleaning solutions as needed. It is common to use a bathroom cleaner like Scrubbing Bubbles or Simple Green to give you a little more help with this process. And remember, you can always do that short soak in 1 molar HCl for no longer than 15 to 20 minutes, or an overnight soaking in white vinegar if you have a really, really horrific hard fouling barnacle type growth that you need some help with. And I'd just like to caution you that if you're doing both, please remember to rinse well before going between the HCl and vinegar, as you'd never want to mix those two solutions together. Let's chat a little further about cleaning some of the individual sensors, as the technique may vary depending on the parameter. Once you've pulled the sonde from the water and cleaned its exterior, it's also important to clean all of the sensors. Let's start with the wipe conductivity sensor. And I failed to mention that's that combination sensor. It also has your temperature on the same sensor. Whether you are using the standard CT or the wipe CT, it's imperative that the electrodes are perfectly clean between deployments and prior to each calibration. If you're using heat shrink sleeves and copper tape, simply slice the copper tape off the sensor with a sharp blade. This will allow you to remove the entire copper skin and will speed the cleaning process immensely. To clean the inside of the wipe CT electrode channel, I like to use a sheet of Scotch-Brite cleaning pads to gently scrub the electrodes clean. Make sure the cleaning pad is wet when performing this procedure. This same pad can be used to gently clean buildup off of the face of the turbidity, total algae, FDOM, and the new rhodamine sensor. The thing you want to remember about that is that those 4 sensors have a sapphire face, very, very tough face, and that clean pad is not going to hurt them. Please don't attempt to clean any of the YSI sensors or the optical dissolved oxygen sensor with this cleaning pad. It can damage the membranes on this type of sensor. If you think about that picture a while back in the presentation, that one sensor had some staining on it that was kind of a burgundy or red color. That cleaning pad would clean that type of buildup off of there in a matter of seconds. If using the standard conductivity temperature probe, the electrodes are buried inside the body of the sensor and are more difficult to access. Use a small brush that was shipped with the sensor to clean the openings in the sensor, both crossways through the hole in the middle of the sensor and also down from the top where the temperature sensor is located. If you have excessive buildup down inside of this sensor, you can soak that sensor first in warm water with a little bit of dish soap, or you can soak it in white vinegar and then brush the electrodes clean. Make sure that whichever sensor that you are using, that you rinse thoroughly with DI water before moving on to calibration. The ISE sensors will all vary a little bit in terms of the cleaning process that you can perform on the membrane or sensor face of the probes. Let's start with the ammonium or nitrate sensor. When deposits, biofouling, or other contamination appears on the membrane, you should gently remove them with a fine jet of deionized water or rinsing in alcohol followed by soaking in the high calibration standard. Finally, gently dab the membrane dry with a lint-free tissue. The chloride sensor is a little bit different. When deposits, biofouling, or other contamination appear on that membrane, you should gently remove them by washing with alcohol and/or gently polishing with fine emery paper in a circular motion to remove deposits or discoloration, then thoroughly washing with deionized water to remove any leftover debris. Please note that the ion-selective membranes are very fragile. Do not use coarse materials, and when I say coarse materials, you may be surprised when I'm referring to paper towels to clean those membranes, as this could permanently damage the sensor. The exception is fine emery paper for the chloride sensor as noted above. I would like to refer you to the EXO User's Manual for further details on all the ISE sensors. Clearly, the most popular of the ISE sensors, the pH and the PHORP sensor, can be cleaned using one or all of the three steps that I'm about to describe. The first and the simplest step is to simply vigorously swish that sensor in a beaker of warm water with a tiny bit of dish soap. If you do this in a small plastic beaker, it's less likely for you to damage the pH glass bulb. Many times, this is sufficient to clean the lightest of dirt and fouling. The second step should be used if after inspection, the pH glass bulb appears foggy or dull. Soak the pH sensor in 1 molar HCl solution for approximately 3 minutes, then rinse thoroughly in clean water. You can even use a Q-tip very gently to dab a little bit of that 1 molar solution and gently wipe off any of that fog off of the glass bulb. And you have to be extremely careful if you're going to touch the glass bulb at all. It can be broken very, very easily. It's also a good idea to let the sensor soak for a few minutes in a little buffer 4 or tap water. This will help leach out any of the HCl that may have migrated down into the reference junction. And for those of you that aren't familiar with that, the reference junction is the junction between the solution on the inside of the pH probe and the atmosphere. The third and my go-to cleaning process is to soak the pH sensor in a 1-to-1 mixture of tap water and regular household bleach. Let it soak for about 30 minutes and rinse clean with clean water or DI water. And then again, let that sensor soak in pH 4 or tap water for a few minutes to help leach any bleach out of that reference junction of the pH sensor. It's okay to rinse the pH sensor with DI water, but never store a pH sensor in DI water, as it will rapidly leach the inside solution out of that sensor through the reference junction, and it'll lead to premature failure of that pH probe. One of the telltale signs that your pH sensor could use this third cleaning step is if your pH sensor is very slow to stabilize when moving from one buffer to another during calibration process. The calibration process is the time when the pH sensor should be at its best. So if you're very slow to stabilize when moving between, say, buffer 7 and buffer 10 or buffer 7 and buffer 4, this is an indication that the reference junction has been clogged with biofouling. Once we clean this biofouling out of the reference junction, the sensor's response time is likely to improve. Let's move on to the dissolved oxygen sensor. The membrane cap on the dissolved oxygen sensor is relatively sensitive. The paint layer can be damaged if you're too aggressive. Do not use alcohol on the membrane, as it will damage the paint. You can gently wipe the membrane with a damp, lint-free cloth. You can use soap and water, and if for some reason you have more severe fouling on the membrane, you can soak the sensor in white vinegar to help soften this fouling. This would be unusual, as the central wiper does a very good job of keeping the membrane clean. If you inspect your membrane and it has lost more than 25% of the paint layer, then it'd be a good idea to install a new membrane on the sensor. Occasionally, you will find that the biofouling has begun to clog the holes in the bulkhead. And this is the area where your depth sensor, the transducer for your depth sensor, is hidden behind those holes. It's important that those holes are free of debris to allow water to flow freely across the transducer. It's also very important that you never try to stick anything into these holes. You should only use a syringe supplied by YSI to flush water into the holes. Continue to flush with clean water until clean water is flowing out of the open holes. If the biofouling is harder in nature, you can soak the sonde in white vinegar to help to soften the fouling. Again, only use a syringe to flush with water. Do not attempt to pry or stick anything into the holes. The transducer is very close to the other side and can be damaged if you make physical contact with it. This could result in costly repairs. After you have everything all cleaned up, it's very important that you take a closer look at your equipment. You want to protect your investment and also make sure that everything is in tip-top shape before your next deployment. You want to make sure that to inspect all aspects of the system. It's very important to inspect any O-rings and replace them if they're cracked or damaged. You also need to clean and reapply Krytox grease to your O-rings. Always put a little dab of Krytox on your fingertip and apply by hand. This will allow you to feel any nicks or cuts in the O-ring. It's equally important to inspect all of your wet mate connectors between deployments. We never want a wet mate connector to dry out. They should always have a clean coating of Krytox grease on the male and female parts of the connectors. It's also very important to clean off old grease occasionally before applying a new pristine layer of fresh grease. Don't forget about the Sondes cable connectors, the cable itself, Sondes bail, chain, and carabiner. Be sure to look for signs of wear and tear. You don't want the chain to break only to return to find your sonde missing in action. We talked quite a bit about using heat shrink sleeves and copper tape to help fight against biofouling. So I thought I'd go into a little more detail about the process of applying the sleeves and copper tape. We have 3 different sized heat shrink sleeves. One larger one that slips over the entire sonde body, smaller ones for all of the sensors, and then a size that's specifically designed to fit the central wiper. They are easy to apply. You just slip the thin heat shrink sleeve over the sonde or sensors and then use a heat gun or hair dryer to apply enough heat to shrink them down to a snug fit around the sonde body, sensors, and central wiper. If you're in a low fouling freshwater environment, you could stop here in most cases, as these sleeves will be helpful in speeding the cleaning process when the system is covered by a soft sediment type fouling. But if you're in a marine environment, the sleeves will need some protection against the harsh barnacles. This is why we finish the sonde body off with a layer of duct tape and shipping tape. And the central wiper and sensors are protected with copper tape to continue the battle against biofouling. Starting with the sonde, once you have the sleeve applied to the sonde, take regular clear shipping tape to cover the area just above the bulkhead where the sensors are installed. You don't want to cover this area with duct tape, as it will block access to your LED lights and your Bluetooth. Then, using a brightly colored duct tape, wrap the rest of the sonde body with duct tape. You might wonder why I suggest brightly colored duct tape. There's actually a couple of reasons for this. Number one, the bright color will make the sonde easier to find should it be lost due to a heavy storm. Secondly, our testing has indicated that the bright colors also have some anti-fouling characteristics that make it difficult for biofouling to get a foothold. I'm not sure why that is. My suspicion is that it's because of the painting process that they use for that brightly colored duct tape. It must have the particles are much closer together and just make it much more difficult for biofouling to get a foothold. But a bright orange or a bright green works so much better over just the original gray duct tape. It's quite surprising. Moving on to putting some copper tape on your sensors. If you're using our heat shrink sleeves, then you will enjoy the time saved in cleaning the sensor body. It's a breeze. In this particular sequence, however, the customer is using regular shipping tape to first cover the sensor. Once you've installed either our heat shrink sleeves or shipping tape, you're ready to wrap the sensor with copper tape. You want to make sure that the tape does not protrude above the edge of the sensor where the data collection is being done. If you do, don't panic. Just use an X-Acto knife and carefully trim the edge off around the sensor face. I like to use a hard, smooth surface like the edge of a Sharpie to smooth out the wrinkles in the tape. The final picture is of a post-deployment picture. The copper tape has been sliced with an X-Acto knife for removal. That's what I was referring to when you remove the skin, the copper skin off of the sensor. Remember, if you're applying copper tape to either the standard CT or the wipe CT sensor, you must cut out around the holes or the opening in the wipe CT sensor so that water flows freely. We don't want to block the flow of water around the electrodes on either of those sensors. I did that once on a deployment and couldn't understand why my specific conductance and salinity values were so low. It's a rude awakening to find that at the end of your deployment. This is one of my Sondes from our Florida test site. As you can see from these photos, having the heat shrink sleeves under the duct tape makes for simple removal. Carefully run a blade of an X-Acto knife down the length of the sonde and peel away weeks and weeks of nasty buildup in about 10 seconds. This will reveal your pristine sonde underneath. The top end of the sonde can be very time consuming to clean. This was an area that I just hated to scrape and scrub and work on it. It ended up being probably about 40 to 50% of the time to clean a sonde before we started taking other measures to help with that fight. We wanted to come up with an easy way to reduce or eliminate this cleanup time. We started running different tests to see how we could protect this area and save time between deployments. These photos show the use of a simple automotive CV boot that fits nicely over the top of a sonde. Zip ties were used to secure the rubber at the top where the cable and chain run through, and around the bottom edge of the CV boot to secure it to the sonde's body. This item costs about $15 at the local automotive supply store, and I've been using this and reusing this same rubber boot for over 4 years. This particular photo is of a triple sonde deployment at our Florida test site. I simply wrapped the top end of the sondes with duct tape before deployment, and then post-deployment carefully cut the tape off to reveal nearly spotless top ends of the sondes. With no light getting into this area during deployment, we did not see the amount of growth that we would otherwise experience. This simple, inexpensive step turns what would have been 90 minutes of scraping and cleaning into about 5 minutes of work. The diagram at the left shows the proper hole placement and size for a PV sonde deployment tube. The picture in the top middle, shows 2 deployment tubes. The one on top shows a tube that was not cleaned for 6 months. The holes are too small and do not allow for proper flow. This will lead to data being collected that is not representative of the actual environment outside of the tube, but rather the microenvironment within the tube. This particular data set is from our friends at the Jacques Cousteau National Estuarine Research Reserve. This sonde calibrated fine in the lab, passed all post-deployment testing. The DO data was very odd and had what we would later refer to as DO fangs. As the tide came in, it flushed the tube with some fresh marine water, and the dissolved oxygen levels appeared relatively normal. As the water inside the tube stagnated, the dissolved oxygen values began to fall. With a fresh tide, the DO bounced back to near normal levels, then again began to fall. This very interesting data set is an indication of how important it is to build regular deployment tube maintenance into your site schedule. These photos from our friends at the Baruch National Estuarine Research Reserve show a handy PVC tube cleaning tool that they designed to slice barnacles off of the inside of the deployment tube between their annual heavy maintenance that includes removal, cleaning, and repainting of the tube. This slide shows our test site in the Gulf of Mexico. We used a power washer to first clean off all of the hard fouling that even our AF paint had been unable to keep at bay. Then we repainted with anti-fouling paint before reinstalling. And my final photo for today is a quick reminder to check your solar panel when visiting your site to make sure that the birds are not helping to drain your battery power. Thanks so much for taking time out of your busy schedule to join us today, and I hope that this information has been helpful. And my hope for you is that you're blessed with health and safety throughout this pandemic. With that, we'll be glad to field questions that have been coming in throughout the presentation. And Michael, if you wouldn't mind jumping back in for this portion, we'd appreciate your assistance.
Certainly. Glad to be back, and thank you so much for that presentation. That was great. We do have quite a few questions lined up, and we do encourage you now at this point, if you haven't had the opportunity to type in your question, please do so in your GoToWebinar interface. Before we jump into the questions, just a reminder that this is the first of a 6-part series. Our second webinar will be held next week, same day, same time. In fact, I believe that every webinar will be held on a Tuesday at the same time. You can, if you haven't registered yet for the other webinars, we do encourage you to do so. Simply drop by any of our APAC Xylem Analytics websites. There's an address right there for you on the screen, and it's easy to find the registration pages. Also, we will be sending out weekly invitations through email, which again is just a gentle reminder to please join us for these fantastic webinars. All right, first question, and it seems to be quite popular. And this was actually answered at the beginning of the webinar, but for those who joined us a little late, yes, this is being recorded, and a link to the recording will be sent to you via follow-up email that will be sent out by GoToWebinar. Also included in that email is a link to a certificate that you can download as well. All right, first question. We actually talked a lot about Sondes in today's webinar, but there's a question, can handheld probes also be affected by biofouling?
Yeah, so your handhelds can be affected by fouling a little bit, but not quite to the extent that you'll see with your continuous monitoring. And typically with your handheld deployments, you're just going to be, putting them in the water and taking them out, not leaving them for a long time. So with your handhelds, just kind of be a little conscious of where you're putting those. So maybe if you're putting it into an area deeply affected by algae, for example, in a major algae bloom, when you pull that sensor out, make sure, or when you pull the handheld out, make sure that you wipe all of those sensors off to get anything off that may have accumulated during your sampling.
Great, thank you for that.
Real quickly, Michael, I'd like to just add a little bit to that so that also when you get back to the lab, make sure that when you're transporting those, your handheld and sensors back and forth between your collection site and the lab, that you take a minute to wash out and clean that sensor guard, because typically you're going to store those sensors moist with a little bit of solution in the bottom of your cow cup or your transportation cup. And if you bring water from the estuary or wherever you're sampling back in, and then you put that up on the shelf and go out the following week, that's where you're likely to see some buildup on those sensor faces. It's just from the growth that can occur in while you have it in storage. So just make sure that you clean everything up really well before you put things away between your next visit.
Great, thanks Curtis for adding that. Our next question is, what is the typical period between calibrations?
So that's a really good question, and that's kind of going to vary depending on the site as well, as some sites may need more frequent calibrations than others, and it's also going to be dependent on your own organization's standard operating procedures as well. So you may need to do a little bit of experimentation. So we would maybe recommend doing a calibration every month when you're starting out, and this is talking about continuous deployment, so maybe check it every month. And then if you see that you're not experiencing any drift between your monthly calibrations, you can maybe try doing a 2-month interval, and just kind of do some experimentation to see what really works best for your site.
Great, thanks, Carrie. There is a question here, not about the cleaning of the Sondes, but what about cables and connectors? Can these be protected as well and cleaned from biofouling?
One of the things that I forgot to mention during the presentation, and I can't remember if I had a slide that may have shown the bottle, but we have a product that's called Sea Spray, and all that is a solution that you spray on equipment into some of those areas where you can't get to very easily, and think of it as a high quality wax product, or if you've ever had the product that you sprayed on the windshield of your car that made water bead up. It works very similar to that to help or deter anti-fouling from getting a foothold on your equipment. So the first thing you can do is kind of coat your equipment with things like that. There's another thing that, and I don't know the technical name for it, but there is a plastic product that it's typically used for corralling a group of wires. So you can essentially wrap your cable with that. So in a marine environment, you can wrap your cable above where it connects with the sonde with this plastic. It's difficult for me to describe it. I have it on my test sites in Florida, and I wish I had the technical name for it. But by wrapping the cable in that flexible piece of plastic, it allows you to break the barnacles and the buildup off of your cable very easily, as opposed to allowing the biofouling to get a really solid grasp on the cable by itself. That's one of those things that I can do a little research and make available directly to you via email.
Thanks, Curtis. And again, if anyone is interested in that question, please contact Curtis directly through the email that's written on this slide, info@ysi.com, or you can reach out to us here in APAC area at info.apac@exyleminc.com. Let's move on to the next question, and that is, how would you identify drifting on DO sensors that could be due to fouling?
So that's a really good question. So with the DO sensors, as you're monitoring your data over time, you'll start to see some trends in the data. So maybe your trend at base flow is around 8 milligrams per liter, and maybe you see some normal fluctuations between 7 and 9 regularly. Well, if all of a sudden your data starts drifting up to 8.5 milligrams per liter, 9 milligrams per liter at base flow values, then you might start to think that maybe there's something on the sensor that's affecting those readings. Or if you see smaller variations, like I said, maybe between 7 and 9 milligrams per liter, and all of a sudden you see changes to where it's now going between 6 and 10, there may be something on that sensor that's affecting your readings. Or there's also the possibility that you'll just see really erratic data, which we call painting data. And that would definitely indicate that there's something on the sensor as well.
And the other thing that you can do also in terms of long-term deployment, you're going to calibrate your equipment before it goes in the water. And then when you go to retrieve that sonde, you're going to take some readings in standards before you clean any of the sensor faces. Once you've taken readings in those standards before cleaning, then you'll do the same thing post-cleaning. And that's how you can differentiate between whether or not you've got biofouling interfering with your data. So just keep in mind that that's a good way at the end of your deployment to double check and make sure that the fouling hasn't been interfering with your data collection.
Thank you, Curtis and Carrie, for that answer. Let's move on to the next question. Does YSI offer a cleaning kit?
We currently do not offer a cleaning kit, but we offer the suggestions that we had on the slide here. The cleaning products that we do offer are going to be like those little brushes that Curtis mentioned earlier, like for the specific conductance brush, for example. So we do sell those.
Great, thanks, Carrie. And we are running out of time, so I'll wrap it up with this last question. And Carrie, I believe this has to do with the Hydrosphere software that you were talking about. Can the alarm of the fouling alarm be set up for all types of sensors in the EXO sensor selection?
Yep, alarms can be set up for any of the different sensors that you have connected that are coming into Hydrosphere. So you could have one alarm set for conductance, you could have one alarm set for dissolved oxygen, one for pH, and so forth. They're all available, and you can have a different alarm for each.
Okay, great. Let me slip in one last question here. You've mentioned in the seminar today that there are several simple cleaning products available in the USA, but these might not be available in other countries in the APAC region. Are any commonly used cleaners applicable to cleaning our sensors and our Sonde?
Yeah, so you could use just commonly used cleaners like maybe a dish soap or yeah, just like a dish soap with some water, just something very mild is kind of what we're talking about here. So when we talk about like the simple green or the scrubbing bubbles, they're not um, very hard cleaners. It's not like a really strong bleach or something like that. We're not recommending that. We're recommending just a mild dish soap that's, okay for you to get your hands in and those kind of things, just something nice and mild.
Great, thanks, Carrie. Once again, Carrie and Curtis, thank you for your time. We realize it's extremely early over there in the US. Welcome to Tuesday morning. And to our audience, thank you very much for participating. Again, we look forward to seeing you at next week's Algae Sensors webinar. Carrie and Curtis, do you have any last comments before we leave?
Yeah, I'd
Just
just like to
again,
say thank you all for joining us. Sorry, Kurt, I interrupted you.
No, that's okay.
So thank you all for joining us. We really appreciate you coming to the webinar today.
Absolutely. Appreciate the opportunity to be with you, and enjoy your dinner.
Thank you very much, everyone. Stay safe and see you next week. Bye-bye.
Bye now.
Bye.